Okay, so let's go ahead and calculate an R statistic for these data from the practice problem on Glenn's website. I want to apologize in advance. The filming is probably going to be a little janky. This was the best that I could do. So we have these data. We have X and we have Y. And we want to see if there is a correlation between these two variables. So the first thing that we're going to do, let's start with X, is we're going to calculate our mean and our standard deviation and all that stuff that we already know how to do. And you'll see it's going to be quite simple. This particular one's going to be pretty simple. All right. So when we calculate our mean, we're going to see that for our X, and we're going to demarcate all of our steps with an X, so we know what variable we're working with. We're gonna find that our mean in this case is 1. All right, I have everything calculated out in advance that I'm going to refer to while I continue the problem. I suggest if you're watching this and you want to use this as practice that you pause the video before each step and do the calculation yourself, and then check with what I have worked out to see if you did it correctly. So now we're going to find our deviation scores, and those are going to be deviation scores of X, remember. So we're just going to subtract across the line, just like we've always done. So we're going to have -1, 0, and 1. Pretty straightforward so far. We're going to start a new column. We have to get rid of those negatives. So we're going to square our deviation scores. And when you do that, you're going to end up with 1, 0, and 1. All right, and at the end here, for our last column, I'm going to put z of x. And these will be deviation scores of x as well. So before we can calculate our z-scores, we now have to calculate our sum of square deviation scores and our variance. So I'm just going to hop down here, and we're going to calculate the sum of our square deviation scores, which, if you remember, the sigma sign is going to be our summation sign, x minus m squared. This is how we're going to add up our deviation scores. So if you add up these 3 scores here, you're going to get an answer of 2. So this 2, this is the sum of the square deviations. And what we're going to do now to find the variance is we're just going to take this exact formula that we have, and we're going to divide it by n, or the number of data points, which, as you might recall, is 3. So this is going to be equal to 2 over 3, right? So our variance then is going to end up being 0.67 when you round it. All right, then to find our standard deviation is just the square root of the variance. All right, so remember, variance can also be represented by SD squared. This means variance. So in order to find our standard deviation, we're going to take this value that we just calculated, 0.67, and we're going to square root it. And what we're going to get as our answer, 0.82. All right, so this is what we've done so far. We calculated our standard deviation. The note in the bottom right is for me. You don't have to worry about that. But we calculated our standard deviation. That's what we just calculated. Just going to fix this. So standard deviation, this is what we just calculated. That's the standard deviation for x. Right, so we want to make sure we put x here, and x here, x here, just to keep ourselves organized. All right, so make sure you are able to calculate standard deviation for that. We're going to go over the standard deviation of y in a moment. And I'm going to write our standard deviation of x at the top so we don't forget it. Okay? And then I'm going to erase the calculations we've just done, get them out of the way. Again, feel free to pause while you're watching this, redo things, make sure you understand everything. So I'm just going to erase what we have here, all those calculations. And now we're going to switch to working with our y values. All right, so we're going to put y here, start a column of y, 2, 1, 3. Those are our y values. We're going to find the mean of these values, which if you do the calculations, you will find that the mean here is 2. All right, so fill 2 into the mean column. Then we're going to do the exact same thing we did with x. We're going to find our deviation scores, which is y minus m. We're going to find them as 0, -1, and 1. All right, we have to get rid of those negative numbers now. So we're going to find our squared deviation scores. So we're just going to square all the numbers in this column, put them over here. So we're going to have 0 and 1 and 1. Okay, I'm going to add a column over here. Okay, I'm actually going to get rid of that for now. We will find our z-scores in a second. I'm just going to add up here too, that we don't forget that the mean of our x was 1. So once I get the standard deviations for both x and y, then I will calculate the z-scores. So I'm just going to mark up there so we don't forget our mean of x and our standard deviation of x. So continuing from here, we have our square deviation scores now. Now we need to find the sum. So it's going to be the same thing, sigma sign, right, y minus m squared. And when you add those together, you're going to find that they add up to 2, right? Add these three values together, you get 2. Pretty straightforward. Okay, and now we are going to find our variance, which is just what we have here, sum y minus m squared, and we're going to put it over n. So in this case, we're going to have 2 divided by 3, right? And we're going to end up with 0.67. Okay, we're going to take our standard deviation now, just like we did before. Standard deviation is equal to the square root of SD squared. And again, this value, we just calculated the variance. This can also be called SD squared. So we're just going to take the square root, 0.67, and it's going to be the same standard deviation as it was before. We're going to have the exact same standard deviation, 0.82. Okay, so hopefully everyone is able to get this far with minimal issue. We did this in class. I'm just going to mark up here so we don't forget our m of y is 2. That's our mean. And our standard deviation y is equal to 0.82. Just so I don't forget those two values up there. All right, I'm going to erase what I have here. Then we'll get our z-scores. And from there, we'll be able to calculate our R statistic. So let me get rid of this. So let's look at z-scores for x first. So remember our z-score formula is z equals x minus m over the standard deviation. That is our z-score formula. So let's find our z's of x first. So I'm going to do the first score. We have z equals 0 minus the mean over the standard deviation, which is 0.82. All right, so again, you should be pausing between each of these to make sure you calculate them yourself and you get the right answer. But I'm just going to keep going. For this one, 0 minus 1 divided by 0.82, we're going to end up with negative 1.22. All right, so that is our z-score for the first score, negative 1.22. Let's look now at our next one. We're going to have z equals 1 minus 1 over 0.82, and that is just going to be 0. Okay, and our last one for x, we're going to have z equals 2 minus 1 over 0.82, and that is going to be equal to 1.22 positive this time. See, the first one we had was a negative. This one's going to be a positive. All right, so those three numbers there, those are our z-scores for our x values. So I'm going to add those to our list up here. Our z of x's are negative 1.22, 0, and 1.22 positive. Okay, so I'm throwing those up there so we don't forget. So again, I'm going to erase these calculations in the middle. And now let's calculate our z-scores for z of y. So we're going to take our y values now, and we're going to remember the z-score formula. So the first one is going to be 2 minus 2 now, which remember was the mean of our y values up here. And we're going to put that over the standard deviation, which in this case, the standard deviation of x and y is the same. So we're going to calculate that, and for this first one, we're going to get 0. Then we're going to do the second one. So our second value for y is 1, so we're going to say 1 minus 2 over 0.82, and that is going to be equal to negative 1.22. All right, and finally, for our last score of y, the z-score is going to be z is equal to 3 minus 2 over 0.82, and that is going to be equal to 1. That is going to be equal to 1.22, a positive. All right, so these are our z-scores of our y-scores. All right, this is z of y. All right, and I'm going to put them up here so we don't forget. Our z's of y are equal to 0 and negative 1.22 and positive 1.22. All right, again, this should be something that's not too terribly difficult. We did this in class. So now we get to actually calculating our r. So I'm going to get rid of this too. Now we have our z-scores for two variables. Now we can calculate our r. So the first thing that we're going to do is I'm going to write the step down. We're going to compute, right, z of x times z of y for each case. All right, so we're going to compute z of x times z of y for each case. And this is what that's going to look like. So let's make a table here. Let's put our z of x's in this column. Negative 1.22, 0, 1.22. And let's put our z of y's in this column. 0, right? Negative 1.22 and 1.22. So now we have ourselves a table, and then we're going to make a third column. That will be our z of x times our z of y. And then we're just going to multiply right across. So negative 1.22 times 0 is 0. 0 times negative 1.22 is 0. All right, so 2 zeros so far. And then 1.22 times 1.22 you'll find is 1.49. Okay, so this was the first step in calculating r. Compute z of x times z of y for each case. And these are the values we get when we do that. So now our next step is to sum the cross products. Okay, sum the cross products. So literally what we're going to do, and this looks like something you should be familiar with, our sigma sign, sum the cross products. Sigma, z of x, z of y, close parentheses. All right, we're going to sum those up. So this one's really easy. Just add these three numbers up. You'll find 0 plus 0 plus 1.49. That is equal to 1.49. So that is the sum of our cross products in this case. Right? And now, all we want to do now, our last step of this whole process to find r, is we just want to take the average. Take the average. All right, and all we're going to do for this is we're going to take that 1.49 that we calculated. Take the 1.49 that we calculated, and we're going to put it over the total amount. We're going to put it over 3, right? The total amount of scores that we have. So we have 3 scores here, so we're going to put this over 3. And what we're going to get is 0.50 as our value at the end of that. Okay, so now we have that. And that is our r. This value is our r. So on the bottom, I'm going to put r is equal to 0.50. Right, so that is our r. So really, it's just a few more steps away from calculating our z-scores, right, which I put up there for us. Once you calculate your z-scores, then all you have to do is multiply across the row of your z-scores, create a new table, right? Your z of x's and your z of y's, multiply them across the row, right? Negative 1.22 times 0 is 0, and so on. Multiply across the row. Then just add up the products that you get. In this case, we got 1.49. Then just throw that 1.49 over how many scores you had, how many cross products you had, which is 3 in this case, and we get our R is equal to 0.50. All right, and this we would call a moderate positive correlation. All right, so that is calculating R. Hopefully you find this example helpful. This comes out of Glenn's website. It's the practice problem on the exam study guide. So yeah, hopefully you find this helpful. This will be posted online for you to see and practice from.